Hey guys, today we're going to talk about stoichiometry. And before we get to that though, I want us to cover a few really basic principles of math that you already know. We're going to talk about how 5 divided by 5 equals 1, okay? Those 5s, they essentially cancel out because we're left with 1. And 1 times any other number, if we have 3, equals 3. If we have 1 times a number of grams, okay, it's equal to that number of grams or meters, whatever the unit, it all works the same, okay? So along with that, if we have two numbers that are the same, they cancel out. It works the same for units. If we have meters, meters on top, meters on bottom, they cancel out. They become 1, okay? So this is super important for stoichiometry, is aligning up our units so that we have the same unit at the top as the bottom so that they'll cancel out. Okay? So now we're going to talk about conversion factors. We've been doing these since like 3rd or 4th grade, and they're nothing trippy, but they might be in just a little bit different format than you might have seen before. Okay, we know that 1 foot is equal to 12 inches. Okay? The way we write these for stoichiometry is we're going to put them as a fraction. 1 foot per or in or divided by 12 inches, okay? Same thing. Now remember, 1 foot can equal 12 inches, but 12 inches can also equal 1 foot. So this can be flip-flopped, alright? And this can be written either way, okay? Same thing if we have 1,000 meters. It's equal to 1 kilogram. All right.
Meter.
Sorry, kilometer. Oh, sorry. Okay, kilometer. We can have 1 kilometer over 1,000 meters, or we can have 1,000 meters over 1 kilometer. All right, they work the exact same way because they represent the same quantity. All right. So Tracy's going to come and she's going to work the first problem using this basic stuff.
Okay, so we're just going to do one real quick and simple example using everything that Brianna just said. So say that you're given a question that says you have 3 feet, and they want to know how many inches that is. So to do that, you would start off and you would write 3 feet. And you want to multiply it to see how many inches you're going to get. But you might sometimes end up having to divide, but that comes in on where your numbers end up lining up. So Brianna was talking about how you have to have feet over feet in order for your feet to cancel out. And you have to have like inches over inches for all of that to cancel out. So if we have feet on the top, we're going to need feet to be on the bottom. So we can go ahead and fill that in because we know that feet are going to be on the bottom. And you want whatever's on top to be what you need your ending unit to be, which in this case is inches. So you write inches right there. And she said that you can have 1 foot as 12 inches or 12 inches as 1 foot. Not I foot, 1 foot. So if we have 3 feet and we need feet on the bottom, we're going to need to use the one that comes with feet on the bottom. So you fill in 12 inches is 1 foot. And unless you're told otherwise, which I don't think in all of the time that I've done chemistry we've been told otherwise, but this is always 1. You always assume that to be 1. So then you just multiply like you would any other problem. So you're going to do 3 feet times 12 inches, and the feet units cancel out because it's like dividing 1 over 1 or 5 over 5 or x over x, anything like that. The feet cancel because it's feet over feet. It's just like writing this. So then you just do 3 times 12 and you're going to get 36 inches over 1, which just becomes 36 inches. And the units are crucial in these. If you do not get the units correct, you will not get the problem correct in any shape, form, or fashion. Brianna is laughing at me, so I'm going to let her come back up here now. Oh, yeah, that mixed beautifully.
Alright, guys. So now we're going to talk about how we can get from one unit to another unit, even if they might not be side by side. Okay, if we all remember the like the step ladder for the meters, where we had like King Henry died drinking chocolate milk. I think that's what it was. And you know we have a conversion factor for each unit, you know, kilometers, centimeters, whatever, directly back to meters. But this time we're going to go from kilometers to centimeters. So in this problem, we're going to have 12 kilometers, and we want to know how many centimeters is that. So we don't have a conversion factor that takes us directly from kilometers to centimeters, but we have one in the middle, meters. Okay, so we wrote earlier that 1,000 meters is equal to 1 kilometer, or 1 kilometer is equal to 1,000 meters. And then we also know that 1 meter is equal to 100 centimeters, or 100 centimeters is equal to 1 meter. Okay, so we're going to start with what we know. We know we have 12 kilometers. And remember, we put this over 1 because any whole number is that number over 1. Okay, and we're going to multiply times, we're going from kilometers to meters, so one of these two. And we want to pick the one that has kilometers on bottom, so we have kilometers on top, kilometers on bottom, and they'll cancel out. Okay, so we're going to choose the first one, 1,000 meters over 1 kilometer, so that those will cancel out. Okay? Now, we're going to keep going, because remember, this leaves us with meters. What are we trying to get to? Centimeters. Alright, so we can make this more than one step. We can add another one, and we can go directly from meters. We can use this now here. Shoot, hang on. Okay. Alright, never mind. That makes it more complicated. Let's just stick with solving it as 2 separate problems. We're going to have 12 times 1,000 meters is 12,000 meters over 1 times 1 is 1. So that leaves us with 12,000 meters. And just like Tracy said, don't forget your units. Super important. Now we're going to take those 12,000 meters and we're going to bring them down here and make a separate problem. You can do it all in one, but for demonstration's sake, I'm going to do it as 2. So we're going to have 12,000 meters over 1. And we're going from meters to centimeters. What's the conversion factor? They'll have meters on the bottom. 100 centimeters over 1 meter. Alright, 100 centimeters over 1 meter. Alright, so we want, so our meters cancel out. And then we're going to multiply across the top, multiply across the bottom. 12,000 times 100 is going to be 1,200,000.
I can't see it.
Over 1. Is it gone?
Yeah,
it's
gone.
Let me write it back up at the top. Technical difficulties.
It's alright, we got this.
Alright, let's start back up here. Alright, 12,000 times 100 is 1,200,000. And what's our unit? Centimeters. Because remember, our meters canceled out down here. Over 1 times 1 is 1. Or just 1,200,000 centimeters. Alright, so that is how we do it. We're going to set it up as 2 separate problems. Now the next problem that Tracy's going to work for us is we're going to have
miles per hour.
Yeah, we're going to have miles per hour, and we're going to use this all, and we're going to take these 2, and we're going to show you how you set them up as 2 equations, or you can make one longer equation and save yourself some time. So that's what she's going to do in the next step.
Alright, so I'm going to do mine in one big step because to me that's easier than trying to keep up with the answer from one problem and put it into the next problem, and I get all mixed up with that. So I'll do mine as one big problem. So we're going to start with, you're given 30 miles per 1 hour. And you want to know how many feet per second that is. As Ms. Bowman taught us well in Chem 1, you always want to use the wiki method. What I know is. So you start by writing your question and what you know. So you start with 30 miles per 1 hour. And then you can flip-flop it around and you can change your hours to seconds first, or you can change your miles to feet first. That's up to you. I prefer to do feet first because it's usually more complicated. So the conversion factor from miles to feet is 5,280 feet is 1 mile. And so then, I don't know why I wrote mile out there, it's not there, but anyway. And so then your miles cancel out. So that leaves you with feet per hour. But we want to be at feet per second. Excuse me. So then you go to the next step, and that is getting your hours to seconds. You can do this in one step, but that always confused me, so I always go to minutes and then go to seconds because it's just easier for me. But so then you want to do 1 hour on top because you need your hours to cancel out, and right now your hours are on the bottom, so you have to do them on top to make them cancel. So you're going to do 1 hour is 60 minutes. And then you need to get your minutes to cancel because we want to get to seconds, not minutes. So you do another one, and 1 minute is 60 seconds. And always, always, always check your units when doing stoichiometry because you don't want to work out all this math and then see that you have the wrong answer just simply because you didn't check your units to make sure that you had them in the right spots. So mile, mile, that cancels out. Hour, hour, that cancels out. Minute, minute, that cancels out. So we are left with feet per second. And when you do all the math, you end up with 44 feet per 1 second. And like Brianna said, you could have done it to where you did this, and then you stopped, and then you did that all together. But for some people, it's just easier to do it all as one because then you can check all your units and make sure that they all line up together.
Alright, thanks so much for watching our video, guys. I hope this was helpful to y'all. Thanks. Bye.